Good morning, one and all present here. Today we are going to see about the introduction of organometallic chemistry. What do you mean by organometallic compounds? That compounds which containing one or more metal carbon bond, they are called as organometallic compounds. The chemistry which deals with such compounds are called as organometallic chemistry. So organometallic compounds which are generally used as a reagents and catalyst for organic synthesis. For example, Grignard reagents, Wilkinson catalyst. And also it is used as a additives, that is tetraethyl lead in petrol. They are classified into different categories based on the nature of the metal and carbon bond, based on the number of carbon atom through which the ligand attached to the metal atom, and also based on the number of electrons which are contributed by the ligand for carbon ligand bonding. So in this video we are going to see about the based on the nature of the metal carbon bond. Depending on bonding interaction between the metal and carbon, they are classified into these types. One is the ionic organometallic compound, and then sigma bonded covalent organometallic compounds, and pi bonded covalent organometallic compounds. Organometallic compound with multi-center bonds and also halides. The first one is ionic organometallic compound. These ionic organometallic compounds which are formed from highly electropositive metals like alkali and alkaline earth metals. Here the electronegativity is nearly 1. The bonding force is purely electrostatic in nature. For example, sodium with cyclopentadienyl, and then zinc with methyl group, and then N-butyl lithium. And then another category is sigma bonded covalent organometallic compounds which are attached by covalent bond, which is formed by B black elements with electronegativity between 1 and 2.5, that is beryllium, boron, silicon and lead. Also some of the D black elements also form the sigma bonded covalent organometallic compounds, that is manganese, tungsten and then manganese, cobalt. Then the shape of the organometallic, these kind of compounds, which is depends on the hybridization on the metal atom. Then pi bonded covalent bond organometallic compounds which are formed from alkenes, alkanes and also the carbon containing the compounds having the electrons in their pi molecular orbitals. The bonding nature of these kind of pi bonded covalent organometallic compounds are overlapping of pi molecular orbitals with the vacant orbitals of the metal atom. The metal atom gets bound to all the carbon atoms over which the pi molecular orbital of the organic ligand is spread. The bonding, it cannot be explained by ionic and also normal covalent bond. It is a pi bonding nature. Some of the pi bonding covalent organometallic compounds are the first organometallic compound, an alkene complex with the formula, that is the platinum with alkene, which is synthesized by cheese, is a Danish pharmacist. So it is called a sea salt. So this is the first organometallic compound with alkene complex. And then the most important compounds in this category are ferrocene, that is a bis-cyclopentadienyl ion complex. And then the organometallic compound with multi-centered bonds. The sum of the electron deficient compounds and occur in polymeric forms like lithium, beryllium and aluminium. They are forming the multi-centered bonds with the carbon atoms. So that is the intermediate between the ionic alkali metals and also sigma bonded organometallic compounds of silicon, tin, lead, like that. So that then lithium, beryllium, magnesium, boron and aluminium, it forms readily with the multi-centered bonds. They are maybe a ionic or normal covalent bonds. The structure of bonding is like that. It forms a polymeric in nature. Then ylides, they are doubly bonded with the carbon atom of the ligands. The main group elements are transition elements. For example, Wittig reagents, chromium, molybdenum, tungsten and iron. It forms a ylides compounds with with the carbon atoms. So that is the bonding nature is nothing but it is a metal and double bond C bond. So this is the uh,